Hello, so today we are going to do this problem called average levels in binary tree. So the problem says we get a root of a binary tree and we want to return the average value of the nodes on each level of the tree. And the answer is guaranteed to be within, any answer basically within this value will be accepted. It doesn't, that portion doesn't really matter. But what this means is basically the first level just 3. So and the number of nodes is just 1, so the average is 3 divided by 1, so it's 3. The second level, 9 plus 2, 29. Length is 2, 29 divided by 2, that's 14.5. And this last level, 15.7, the sum is like 22 divided by 2, and that's 11 as well, right? And so that's the idea. Just sum up the levels to get the average of each level. Just get the sum and then divide it by the number of nodes. So pretty straightforward there. So yeah, obviously this is a tree, so we should probably be able to solve it either with BFS or DFS. I'll start first with BFS, and then from there we can try to solve it with DFS. Okay, so for BFS, since it's easier because with BFS it's really intuitive to get levels, because each time you put in the queue the next level, and then we can just fill the levels and then just calculate the average and add it. Okay, so that's what we will do here. So that would mean, let's get, we need our levels to start first at the root node, and then we need our result array that will contain averages. Let's actually call it averages. And we need to do while a level, right? We will traverse the level. And then we'll do next level. So this is to keep track of the next level that we'll get from the children of level, because let's say when we are traversing 20 and 9, let's say we had another subtree here. What we want to put the immediate children for 9 and the immediate children for 20 in next level, because both are the next level elements, right? And so we'll need to traverse, which means we'll need to traverse all the nodes in level, and for each get the children. So for child in node.left and node.right, so let's just call it node.left and node.right. We need to check if it's actually a node that exists. So maybe, for example, this one has 20 had just the right child, or maybe we had only a left child here and nothing here, or just for 9 where there is no child. So both of left and right would be none for 9 here in this case, for example. So we want to check to make sure it exists, and then if it is, we want to add it to next level. So far this is just doing BFS on the tree, and then before going to the next iteration, we want to replace level, because we already processed it, with the new next level that we want to process next. So to do that, we just, in Python, we want to copy it though, to prevent issues with accessing the same things again. And now, when do we need to add to averages? Well, we have the levels here, right? Before processing them, we have the levels, including when the root is there. So we can just add it here. So we can append the average of this level. What's the average? It's just the sum of the level divided by the number of elements. We are doing division like this intentionally, because we wanted the float number like this, right? Yeah, I think that's pretty much it. So let's just return our average here. Averages, and we should run this. Okay, yep. So here, this is the level has nodes and not node values. So we need to get the node values. So to do that, node.val for node in level. For the length, yeah, we don't need to convert it to node.val to get the length. So let's run this. And let's submit. Okay, so that passes test cases. Now we use DFS. Let's see how we can use BFS here. So to do DFS, yeah, let's actually just do it. So we need to go from the nodes, and we know that with DFS we need to do left, we need to pass something, and then we need right. So what's important here is the levels. So what's important, the problem with DFS is it goes all the way down. So what we need to do is just each time records the depth. So somehow for each depth record all the nodes. So for depth 1, let's say 3 is depth 1, or maybe 3 is depth 0 because it's the start. Then we want to record the sum and the length. And here for depth 1, we want to record the sum and the length. And so as we do DFS, even though we'll do these two in two different calls, if we maintain just a depth and then add to it, maybe using a map where depth is key, then we should be able to at the end get a map where the depth has all the data we need. Once I start writing this, it will be clear. So we would have, so we need to record the depth, we said, so let's have a depth here. So for the root, let's say the depth is 0, right? And we need a collection to record depth, right? So let's call it maybe levels, to record the levels for us. And let's just initialize it to a dictionary with some default value. So what do we want to record? What are we interested in for the average? We want both the sum of values and we want the length, right? The number of nodes. So this is the pair that we want. So let's just exactly record that. But for our collection, so if we start from 0 here and from 0 here, we can just add the value each time and add the node +1 for the node each time. And so what do we need to initialize it with? 0, 0, right? And so just to avoid checking if it's in the map, initialize it to this. If it's not, then don't initialize. Let's just initialize it here with the dictionary. So we can do that with lambda like this and just say we want the default to be 0, 0. Okay? And now when you are at a node, and when we are at a node here and go right, well, we increase the depth by 1. And when you go here, you increase the depth by 1. When you go here, you increase the depth by 1. So here it was 0, and here we increase by 1, so it's 1, and here it's 2. And we need to pass 2 here, for example, to both the left and the right. And so that's why we need here to pass the depth +1, and here to pass the depth +1, right? And so let's just do that. So we need to pass here depth +1 and depth +1. And now here our levels for this depth, right? The key is the depth, so let's just make sure that's clear. The depth, index, and then the value is this. So what do we want? We want to add to the sum, right? So 0, we want to add to the sum this node's value, and we want to increase the number of nodes by 1 because we are processing, let's say 20, and maybe we processed 9 before, so the sum for level 1 is 9 right now. So we want to add 20. And we want to add 1 for the number of nodes, right? So that's what we do here. So we need also to add 1 to the number of nodes. And that's pretty much it, actually. But we want the base case. So if we are at the end, there is no node there, we should just return and do nothing. And so now we should have our levels. Let's just print to make sure we got everything right. Okay, so you can see this is using this tree, by the way. So if we take a look at the result we have 3 for depth 0, we have 3, 1, so that's correct. For depth 1, we have 29, which is 20 plus 9, and then we have the length 2, and same thing for the second, 22, and the length is 2. So we are good there. Now we just need to, for each level, take the sum and divide it by the number of elements. Take the sum divided by the number of elements. So that should be straightforward to do. What we can do here is just return the sum, let's call it SM, divided by the length, let's call it L. And this would be for the sum and L in the values of level, right? So the values of level are the ones that we want. In levels dot values. Okay, and let's run this. And let's submit. And that passes as well. Yeah, so that's pretty much it for this problem. We saw two solutions, DFS and BFS. Please like and subscribe, and see you on the next one. Bye.